have n rooms. Okay, which means I will have n room IDs. Now room IDs, which means for those n rooms, the room IDs are numbered from 0 to n minus 1. Okay, great. Now I'm also given a 2D integer array called as meetings, which represents that, okay, meeting of 0 will be a 2D array saying, will be a 1D array saying, okay, start time, end time. That a meeting, that specific meeting will start at the specific start of I time and will end at end of I. But yeah, that end of I is not inclusive, which means it is exclusive. Which means if you can see, the bracket is open bracket, not closed bracket. So this is how I will have m number of meetings. Okay, now how these meetings are allocated to a room, this is defined in this below rules. The rules are that meetings are allocated to the room in the following manner, by the following rules. First rule is each meeting will take place in the unused room with the lowest number. So if I am, let's say, again, we will just keep track. Okay, let's say I have these meetings M1, M2, M3, M4, M5, and let's say I have room numbers R1, R2, R3, and so on and so forth. Let's say I have 3 rooms, right? Again, although the indexing, which means although the room numbers are based on 0, but let's say we have R1, R2. For the simplicity, we have taken the numbers like this. We will make sure in the code that we have 0 from 0 itself. So it says that each meeting, let's say I have a meeting 1, so it will happen in the lowest numbered room number, which is unused. So right now in the beginning, no one is used, so everyone is unused, which means all the rooms are free. Out of all the free rooms, I'll choose the lowest number room, and in that room I will have my meeting. So in this right now I will have a meeting 1. Okay, great. Then next time I have a M2. So you will see that the free rooms available for me are R2 and R3, because R1 is, let's say, still occupied with the meeting 1. Let's say meeting 1 is still happening in R1. Then this meeting will actually be happening in room 2, because it is the lowest number and it is the lowest number unused room. But Aryan, what if, let's say, a next meeting is happening, but before the next meeting is about to begin, because you know when the meeting is about to begin, because you have a start time and the end time. Let's say you have start time and end time. Let's say the start time was a 5, let's say the start time was a 10, and end time is, let's say, 12, right? But this meeting 1, let's say it had a start time as 0 and end time as, let's say, 5. So when this meeting 3 would be started, for sure this meeting 1 would have ended. So I can just say these people would have gone to their homes, and thus the meeting room 1 is now free, which means the room 1 is now free. So now we can see available rooms are room 1 and room 3. So out of those, the smallest room ID, free room, smallest room number is actually room 1. So this meeting will happen in room 1. That is how actually your meetings will work. Okay, cool. Now next point is, again, I'm stressing on this fact because these 3 rules will define how and what data structure you will use, and also they will define that how you will progress in your approach. Okay, next, and by so far, with the words which I have spoken so far, you must have figured out what I am speaking and what data structure should be used for the specific operation which I was telling you. Okay, no worries. Next operation is, if there are no rooms available, the meeting will be delayed until a room becomes free. The delayed meeting should have the same duration as the original meeting. What it means, what it tries to say is, let's say all the rooms were occupied. Let's say all the rooms were occupied. Okay, let's say I am at the meeting 4, but all the rooms are occupied with meeting 1, meeting 2, meeting 3 respectively. Now meeting 4 will happen, for sure will happen, but as the meeting rooms are occupied, so it cannot happen right now, but it will be delayed until any one of them, whosoever will finish first, I will go and like have my meeting in that specific room. For example, like I had room 1, room 2, room 3, and let's say all the rooms were actually occupied with some time occupied. Now we know that the meeting room 2 gets freed first. right? Meeting room 2 has the smallest ending time, which means it gets freezed first. So I will go and like keep my meeting 4 in the meeting room 2. And that is what it says. But let's say the meeting was from start to end. So let's say the duration of this meeting was, let's say, 10 minutes. Although the meeting is delayed, but still, if it is happening in room 2, it will happen late. I know it will happen late, but it will happen only for 10 minutes. Like it will happen for sure for 10 minutes. Cool. Okay, this is what point 2 says. Point 3 says that when a room becomes unused, meeting rooms that have an earlier original start time should be given the room. Which means, okay, as we have discussed also before, that if a room becomes unused and meetings that have an earlier original start time, which means I will for sure have to sort my meetings on the basis of their start time, because the meetings have a start time. The meetings having a smaller start time will actually happen first. And if a meeting is happening first, it should be given the unused room, which is not used or which is not occupied right now. So this is what the problem 3 says. Now, what I have to, again, these 3 operations which I have to perform can be pretty complex depending upon how you solve it, but we will go on sequentially. Now, what we have to go and deliver is, we have to return the number of rooms that held the most meeting. As you can see, room 1, room 2, room 3, they will actually have some meetings in them. I have to tell the room ID which will actually have most number of meetings. And meetings, how they will happen according to these 3 scenarios. But Aryan, what if 2 room IDs, let's say R1 and R3, both the room IDs have equal number of meetings held? Then what to do in that case? Okay, in that case the problem says that if there are multiple rooms, then we have to return the lowest number, which means we will return R1. Also remember this fact, because this is also very useful. I took 7 minutes for the problem explanation because it is actually a very, very important thing to understand everything what the problem says. Now, they just tell you what half enclosed means, which means it starts at A but ends before A. Now, we will take this specific example, and from that itself we can derive the entire formula, everything from like entire what all data structure we are using, how we can improvise that entire brute force. Everything will happen with this example itself. Let's see. So we have R1 and R2. Firstly, we saw one thing, that the meetings that have earlier original start time should be given the room first. So we will have to for sure sort my meetings in the basis of their start time in the increasing order. Having a smaller start time, this meeting should happen for sure first. I cannot have a meeting at 1. Like for sure a meeting at a 0 time will happen at a 0 time. It should happen before then the meeting which should happen late. So I will for sure have to sort these meetings in the ascending order. So one operation I have known so far is I will sort my meetings in the ascending order, which means a simple sorting. So I will have my meetings and I will simple sort it. So you will see in the code we have a simple sorting of the meeting. And again, I am parallelly showing in the code also so that you can actually relate, because it can be a pretty complex portion if you had not seen scenario problem. Cool. Now we know that, okay, with the first meeting both the rooms are empty. Again, we have taken R1 R2, but their IDs are 0 and 1. Cool. No worries. Now we will have, okay, when we are the first meeting, both the rooms are empty. Oh, so I have to also keep track of what all rooms are empty or not, which means I will keep track of the free rooms, saying, okay, these main number of these all room IDs are actually free right now. Okay, so right now I can see both the rooms are free. Okay, both the rooms are free. So basically I have to keep track of what all rooms are free. So I will keep a data structure called as free rooms, which will tell me what all rooms are free. But you also remembered with this fact that even if I'll just erase the things and I will just highlight again of what the problem was saying. Now I will again go and say that even if a room is free, I will have to use the lowest number room. So okay, I will have a data structure which will say these all rooms are free, but in that all the rooms which are free, I have to get me the lowest numbered room which is free. So in that I have to get a smallest room ID. Out of this free rooms, I have to get the smallest room ID. Now one basic operation is, you have a data structure in which you have room IDs. You have to get the smallest room ID. You can simply sort it down. That is one operation. That is one operation. Other is you want to grab the smallest or the largest element, then you use a min heap. So I know one thing, I have to grab a free room with the smallest room ID, so I can simply make a min heap of that. So this free rooms, which is a data structure which will store all the room IDs, will actually be a min heap because of the requirement of the problem. And that we did not do anything, we just read and went about how we will be simply going about and allotting a meeting to a room. Okay, so far it is great, well and good. Now we come on to my next room. By so far you will see that meeting room 1 is still occupied, so it will go out of my free rooms. As soon as a room is occupied, it will go out from my free room. It will go out. Okay, great. But Aryan, like from a data structure which is min heap, removing out anything will take O of n time. No, only removal out of smallest element or the largest element takes O of log n time. Bro, if you are occupying the smallest room ID room, for sure you will remove the smallest room ID room itself. No, yeah, that is the reason you will remove the smallest room ID room, which smallest room ID room, because it is now occupied with the current meeting. And we will only be occupying the smallest room IDs always. So I will always be removing from the free rooms, I will always be removing the smallest room ID ones. Cool. Now we are at the next room. My free rooms only indicate that, okay, I have only one room free, which is R2. And also, I will also have to keep track of this available room, right, Aryan? Which means, what if my room 1 would have got free? Oh, yeah, that is one thing. Okay, right now you are saying that room 1 is occupied and my free rooms contain only room 2. That's a valid question. And you can also see that, okay, my next meeting, which is meeting 2, will actually happen in room 2 itself. But there's a slight chance that what if in that duration, which means although my meeting 1 is starting at the one time, but what if at that time, what if my meeting 1 was just for this time, from 0 to 1, which means my meeting 1 my room 1 would have been freed up by that time. Oh, so remember this fact. It can also happen that as soon as you are encountering a meeting, your previous room, your any of the rooms would have got freed up. Oh, so how I will keep track of that? Like, what all I need to keep track of? So firstly, let's say we had some specific time. Now, if I am at specific room, I will go and ask the free rooms. But before that, I have to also make sure that if any of the other rooms in my existing rooms are actually freed up or not. How I would know that? If my current start time, because I am in the meeting, so it is a meeting start time. Let's say meeting MS, meeting start time. Now, in any of the rooms which are already occupied, let's say I have a data structure which will have all the rooms which are occupied. I will have to grab out, okay, the smallest end time meeting room. Again, no worries if you don't understand this, we will actually expand the example later on more to actually make you understand that fact. But yeah, right now, if I am at the current meeting, which is MS, let's say if this was a 1, imagine for now. So what would have happened is, this is the smallest meeting ID. So if I had this data structure contains all the meetings which are actually happening in the meeting room, and I just want to figure out if any rooms get freed up or not. So let's imagine that we had a meeting, let's say 0, 1, and again other meetings also happening in the same room, like data structure saying, okay, these are the occupied meeting rooms with these specific times. So let's say something. Now, if I want to say if any of the available room gets freed up, then from this I will grab out the specific meeting which have the smallest end time. Again, smallest end time. Now, if that smallest end time, if it is more than my current start time, which is MS, so for sure, if I grab the smallest end time in all the meetings which are happening, if it is even larger than my current meeting, which is I'm about to go, then for sure all the other will always be large, right? Obviously. But if the smallest meeting ID, if it is less than or equal to my current, which means before this is about to happen, I can free up that meeting. I can free up that meeting, so that meeting room will be free. Oh, so basically you will see that I was requiring in this data structure of occupied rooms in this data structure, I required end time, and I also required the corresponding room ID of that meeting which was occupying that room ID. Now, again, no worries if you didn't understand that, we'll go on and see much more later. But yeah, that is right now we have thought of that it can also happen, and we have to keep track of a data structure containing my end time and corresponding to that end time, okay, what room ID it was occupying. Because if this end time, I will grab the smallest end time, again grabbing something smallest. One thing is doing a sorting, or more optimal is using a min heap. In that also, if I grabbed out the specific element and if it gets less than the current meeting start time, which means, bro, I can simply remove this meeting. Okay, remove this meeting, and thus this specific room ID will get freed up. And actually I can say that right now this room ID is actually free. So this is what we can actually perform. But right now you can see my smallest end time is actually very large, so I cannot free up this meeting. So I cannot free up anything. I just occupy the specific room. As soon as I occupy it, one thing is done, that my room 2 is also occupied, which means now my free rooms, out of my free rooms, nothing remains. So again, one very brute force way will be that simply we sort the remaining free rooms. But yeah, we will simply use a priority queue or a min heap to actually get the least specific room ID. And same way you will see that, okay, for my free rooms I will keep track in a priority queue, which is a simple, as you can see, it's a simple min heap. This is a structure of a min heap in C++. Now okay, now we come on to our next room. Okay, next room, again, its start time is 2. I will see that both the meetings end time is 5 and 10. Now you'll understand much more. 5 and 10, which means when my 2 is about to come, I will grab from this all the occupied rooms, because I know all the rooms are occupied. Even if not occupied, still I will just try to see what all can actually become unoccupied. So right now when I see that, I will see, okay, the least end time in the occupied rooms is actually a 5, and the least end time is itself more than my current start time, which means no matter what, I cannot free out any rooms. Before I start my current meeting. So this meeting will have to be delayed. But okay, I know this meeting have to be delayed, but in which room this meeting will go, that's still a fact, because ultimately you will have to make sure this meeting goes to some room. For that, the same way, the meeting which will end first, which has the smallest end time, which is 5, this meeting, I know this is a meeting, although I get to know that all the meetings are occupied. If the meetings would not have been occupied, I would have simply said, bro, whosoever is unoccupied, simply allot that specific meeting to that meeting room. But right now all the meetings are occupied, but still I know this meeting will have to happen. Maybe it is delayed. So I will grab in this specific all the room IDs, all the specific collection which I have of the occupied ones. I'll grab the smallest end time. Which is the specific 5. I'll grab that. I know, because it is the smallest end time, so I know it will be finished first. So if it will be finished first, I'm just anticipating future. If it will be finished first, then I will know, okay, I will go and hijack this specific room as soon as he finishes. Which means for this specific, I know the meeting duration is 5 minutes. So I know one thing, I cannot shrink or expand my meeting. The meeting will happen for sure for 5 minutes, but I also know that the first meeting room to get free will be at 5. So I know the next meeting, which means this meeting will happen, it will happen at 5, but it will also happen for 5 minutes. So now this meeting will actually become, as start time will be 5, end time will be 10, because I have to keep the fixed duration of 5 minutes for sure, but the new start time will depend upon how and when the previous meeting gets finished. Thus you will see that this specific meeting will have to go on to my room 2. But Aryan, there are multiple things happening. Okay, you told us that you will, in the all the occupied rooms, you have to grab out the room having the minimum end time. Okay, for that I will use a min heap, which will keep track of the minimum end time, which means I have to keep track in my data structure. I will have to keep track of the end time. But Aryan, how would you know that in which room I have to send this new meeting? That's a question still, right? For that, okay, I will also have to keep track of the room ID. So I will keep track in my data structure. I will keep track in a pair. Okay, end time and also the room ID. I'll keep track of this. And when I will grab out and I will sort this, which means basically I will sort this data structure on the basis that, okay, if I grab the top element, that will be the most minimum end time. And that I know I can replace. And whatsoever room ID is there, I will keep my upcoming meeting in that specific room ID, which is here in this case room ID 2. Let's see how this happened. So basically, I know that let's erase everything so as to make it much more clear. So I know that I can, this one is the meeting which will finish last. So I know, okay, the time it will have this upcoming meeting, it has a time of 5. It will happen for 5 minutes, but this meeting will end at 5. So this meeting will end at 5. So now this specific meeting will be represented as, okay, this meeting will happen starting at 5 minutes for 5 minutes. So basically end time is 10 and it will happen at the room 2. And that's how I can say that I have booked this specific meeting. So I have to grab the smallest end time. So I will use a data structure in which I will be grabbing the end time that should be sorted on the basis of their smallest end time. I will use, again, you can simply sort it and you can improvise that, which means in the interview you can simply sort it, or you can improvise that by using a min heap, and thus you can just keep also track of the room ID, because you will have to allot that specific meeting to a specific room ID, and you should be knowing that this end time belong to which room ID so as to allot that. Cool. So you need another data structure will come in picture, which is the priority, which is again currently occupied rooms. This I represented as PQ in my code, currently occupied rooms. And as I told you, I will have a pair. This pair will represent end time and the room ID, end time and the room ID. And for sure that I will have to make it a min heap. So to make it a min heap, I made a custom comparator, because I know that needs to be sorted on the basis of their end time. And again, end time, smallest end time should come first. So you will see if I have 2 end times, so the smallest end time, again, in your min heap, to represent smallest, you actually have to put a greater. It is not like a standard sorting in which you put the less than for the smallest, which means if a of 0 is less than b of 0, so it means that it is sorted and a, which means whatsoever is smaller will come first. That is usually how in a vector works, but in a priority it is opposite. If I put a dot second is more than b dot second, which means whosoever is smaller will actually come first. Cool. So I am saying if my end time is same, a dot first is end time. If the end time is same, then bro, please sort it on the basis of its ID, because I will grab, if the end time is same, I'll grab the smallest ID. That also is a condition. For us. If the end time is same, I'll grab the smallest ID, lowest number ID. I have to grab out. Now, what if the end times are different? Then I'll grab the smallest end time. And that's how I can simply sort my priority queue. Now, okay, when this portion is done, let's move on further. Now we have the next meeting, right? Next meeting. Again, you will see none of the rooms are free. So you will again go and ask, bro, give me none of the rooms are free, and none of the rooms will actually get free even if he's coming, because he's coming at 3. I'll see smallest end time is 10 and the minimum end time is 10 itself. So even if I am coming in, still by that time none of the meetings are getting free for sure. If that is the case, bro, simply you have to get your meeting delayed. Now I have to go and grab in which meeting room I will actually keep, or basically I will actually have my delayed meeting. So I will grab, okay, from this grab the minimum end time. Okay, bro, minimum end time is 10, but that is of two IDs. Both R1 and R2 are ending at 10 now. Oh, so as you have seen in our case, we'll also sort by the minimum RID, room ID. So he will grab, okay, end time is 10 and room ID is room 1. So this current meeting, which is actually of 1 minute, because the diff is 1 minute, end time and start time, this is a 1 minute meeting. This 1 minute meeting will actually be happening in room 1, starting from a time of 10, from a time of 10, and the end time for this meeting will be 10 plus the diff, which is 11. So this meeting will happen at this time duration in the room 1, and this simply we can solve it by the same operation which we saw above. Now let's see the code of this specific portion, how this will look like, and that's the most important piece of code. So as you saw that firstly you have to sort the meetings. Again, I have showed you every step wise that how things are happening. Remember that you have made a data structure which is priority queue, which will keep track of the currently occupied rooms, and you also have the meetings which will keep track of the meetings in the sorted of order of their start times. And you also have thought that you have a priority queue called as free rooms, which will give you what all rooms are free right now. Cool. Now, so as you can see, now I'm very good to actually show you that what all stuff are happening. And again, the improvisation which we have done at every step is, rather than sorting, now we are actually, or rather than iterating on from the small to large, I'm using a min heap to grab out the minimum element. That is improvisation which we have done on every step. If I had gone on and said, bro, let's improvise that, and I have broken down to actually different methods, it would have become a very long video, because every step can be improvised in that by using simply a min heap. So if I'm at the current meeting, you can see I'm going on iterating on all the meetings. If I'm at the current meeting, again, remember this time, remember these lines, because I'll show you the clubbed code all together, but I'll not explain this part again in that portion. So when you have the meetings, okay, meetings, you will go on to all the meetings. Right now I'll say current meeting is start end. Now while this, remember this PQ represents occupied rooms. So I'm saying if I have occupied rooms is not empty, which means all the rooms are occupied, or basically not all the rooms are occupied. I'm saying I have some occupied room. I have occupied rooms is not empty, which means I have some, at least one occupied room. Then I can actually go and check, okay, if I can remove the occupied room or not. So I'll go and check this will get, okay, occupied room, smallest end time. Again, occupied room, smallest end time. This first indicates end time, this indicates smallest. So occupied room, smallest end time. If it is less than or equal to my current start, which means I can free up that room. So I can simply free up that room. And as soon as I say I can free up that room, I'll simply say occupied room having the smallest end time. I'll get its specific room ID. The dot second indicates room ID. So I'll get that room ID and I'll simply say now this is a free room for us, and simply remove that specific meeting from my occupied rooms. My occupied rooms, simply remove that specific pair. Remove that because now it's not occupied, and keep on doing it until you can actually can remove those meetings or not. Simply keep on removing the existing meetings. Now, I have not even started to allot my current meeting. I have not even started to allot. I have, before even beginning to allot, I have freed up. As you can read also, if you want to read, I have freed up the existing meeting rooms which were occupied, which had the smallest end time, which had the end time less than equal to my current start time, the meeting which I am about to perform. And remember, the meetings are sorted in the basis of their start time. So no meeting which is having a start time less will come in future. Now comes the interesting part. If you have a free room, bro, simply allot the current meeting to that free room, but smallest free room. So if my free rooms are not empty, which means I have a free room with me, then I will say, bro, do one thing, book that room. Book that smallest free room. So smallest ID, again, free rooms are top is the smallest ID room. I'll grab and I'll simply book that room with another meeting. plus plus says, okay, one more meeting is booked for that room. So I will have to keep track of the booking also, because ultimately remember, maqsad nahi bhulna hai. Our aim was to give me the number of rooms, okay. You have to like return the number of rooms, like the number of the room that held the most number of meetings. So I have to keep track of the bookings happened in a room, and that room ID I have to return. And also for that room ID, I have to return the smallest room ID itself. We'll keep track of this, but yeah, we have to keep track of the frequency of the bookings happened on that room. So I'll increase the frequency. Okay, one more meeting happened at that room. And also if a meeting is happening, so I have to push in, okay, what is the end time and the room ID for that specific booking happened. So I will push in the end time and the room ID. Again, it's the exact same room ID. I just push in my occupied rooms, because now that room is occupied with that up till end, that specific end time, and with that specific room ID. And now you know that that room is no more free because it is now occupied, right? So please remove it from your remove it from your free rooms. But Aryan, like you said that, okay, what if the rooms are free? You have some free room. What if it is not free? As we had seen in these two cases, in this last case, in this specific case, we saw like when the last meeting was happening, the room was not free, and the same way we saw when the third meeting was happening, the room were not free. Yeah, in that case, we know the meeting will be for sure delayed. If the meeting will be delayed, I will know one thing. I will grab the occupied room having the smallest end time. Again, occupied room having the smallest end time. What is the room ID for that specific occupied room having the smallest end time? I know I will have to book that room with the upcoming meeting. So I will book that room with the upcoming meeting. Now I know that this specific, okay, I'll book that room with the upcoming meeting. That is what I know for sure. But I also know that this room ID will now be occupied with a different time. It will have a different time range, as you have seen also previously. If I go back and show you, yeah. So this was the meeting which was about to get occupied. So now I will have to remove this and will say now the new time range is 10,11. Or basically in my priority queue, I will keep track. Again, remember, in the priority queue, I keep track of the end time and the room ID. So now I will have to remove this and will say now the end time is 11 and the room ID is now R1. So I'll just do the same thing, that I'll remove that specific existing occupied room, that which I have taken right now because I have updated that. So I'll remove that. Now I will push that with the new end time and the room ID. As I have allotted the room ID is nothing but this same stuff which I have stored here, right? This is the pq.top which I have stored here, and dot second is the room ID. So I just put that thing, and this is the end time. End time will be existing end time plus the diff of the time which I will have to track. What I mean by that is this is the existing end time, which is 10. So this, but I have to give in my data structure. Where is this gone? Yeah, in my data structure I have to give 11. What is this 11? The existing end time plus the diff of the current meeting, which is the actual one. So I have to add that in my end time to get a new end time. So that end time I have to keep track. So I'll just simply say now I will push back the existing end time plus the current diff of the meeting. This will be my new end time for that specific new room ID. And that's how I can simply, this is the main piece of code which will actually is the easy, like hardest portion of this entire thing. Oh, I'm saying it is easiest. Now this problem is finished. That's it. So you saw that you improvised many stuff by simply using priority queues. We used two priority queues. So I just show you everything at once. Now you have used a booking. Aryan, why did you use booking as a map and not an unordered map? Because if you had made sure one thing, you can use an unordered map. But if you remember, booking, this entire booked thing is used to keep track, okay, for that specific, this is a room ID. For that room ID, how many bookings were happening? How many bookings happened? It just stored that specific part. Now, for that specific part, a simple question. If I ask a simple question, if I have a room ID and the frequency of booking happened, let's say for room ID 3, let's say if you are using unordered map for the room ID 3, for room ID 2, for room ID 1, for room ID 3 booking happens, let's say 5, for room ID 2 booking happens, let's say 2, For room ID 1, booking happened as, let's say, 5. Now, if you had remembered, you have to give, okay, what is the maximum number of booking happened. For that, you have to give the room ID. Now, you would have given room ID, okay, you will have simply grabbed, okay, what is the maximum frequency? Maximum booking happened. Let's say maximum booking happened, you have grabbed as 5. Now you will go on and iterate on your data structure, which is the simple unordered map, and then you can have simply grabbed whatsoever is the first came in. But that would be wrong, because unordered map does not sort your keys. So you would have given the answer as 3. Although the hack can be that you go on and iterate on all the keys who has a frequency of 3, and then try to minimize your key itself. So that can be a solution, correct solution. But what I'm saying is, no worries, bro, don't keep track of all this. Just sort the simple keys. Again, you can also solve this by using an unordered map of booked, and also by simple map, but the complexity will not change, because we are already using priority queues and stuff, which will actually be of the log n complexity itself. So having a new data structure, having a log n will actually not hamper us, but still you can improvise that if you want. So now I can simply do, okay, my maximum number of bookings are 5. I'll go on in my data structure, the first ID which will give me this corresponding booking, maximum booking, that will be my answer. So I'll return that specific room ID. So that's the reason I took a map. But again, you can also take an unordered map. It's just that you have to modify our code a little bit. Now, as I showed you, I will use a priority queue. This gives me occupied rooms, and this will store the end time and the corresponding room ID. Again, end time and corresponding room ID, this will actually store. Now, I will simply have also a free rooms. That also is a priority queue, also a min heap, because I want a room ID having smallest possible. I grab the free room having a smallest possible room ID. Now I will simply say in the beginning every room is free. So I'll push all the rooms in the beginning as free rooms, because you know in the beginning every room is free. Now I will simply sort the basis on the basis of their start time, because I will go on the start time order. Then this is a piece of code which I explained you very well, that how actually the entire stuff is happening. Firstly, he will actually try to remove all the rooms which can be, before even starting to look for the meeting room, he will try to free up all the rooms which could have been freed up before the start time. Then he will try to look for any free room available. If not, then he will try to look for any booked room but having the smallest end time. And ultimately I will have my this specific booked array, like booked map, I will have correctly populated with the correct frequency of meeting rooms, which means this booked contains key and value. Key contain your room ID and value contain your frequency of the meetings held in that specific room ID. Cool. So I'll simply have and say whosoever has the maximum meetings, just grab me that specific room ID. So I'll grab that specific meeting room is the specific room ID which I will grab, and that will be my answer, which means this specific meeting room will actually be holding, what is holding? We actually have the maximum number of meetings happening. And this is what I can do in the final loop. And that's how your complexity will be nothing but O of m log m. Again, that will be n also coming in picture, but n is very small. N is nothing but the number of rooms as in the room ID, and m is the meetings which is happening. And you can see with the constraints itself, if I go up, the constraint itself, meetings are actually very much, but the rooms are actually very less. So for sure the end factor will not give much impact to your solution. So you can just simply go and say your complexity is m log m. Again, everything is included: sorting, priority queues, which means 2 priority queues, and maps which you have used. Space is also O of m, but I have written like O of m plus n, although n will not matter because it's very small. M will be the only factor which will determine that. Cool. And that's how you can simply solve it. I know that's very high. Cool. Goodbye. Take care. Bye bye.